In order to study this part of this module, students must necessarily have studied and understood all of the modules up to this point. Otherwise this won't make sense. Proximity to foreign structures. Foreign structures include pipelines and anything that could cause a disturbance to the natural electrical equilibrium of the ground itself. The two half-cell surveys and DCVG compare the potentials on the surface of the ground and are included in the following link, and you will see a link button. The most commonly quoted is railways, which are driven by DC charges. These are carried in overhead cables and return via the rails, which are earthed. This means that there are surges of DC charges in the ground itself, which will take the least line of electrical resistance to complete their particular circuit. Remote earth is a resistanceless conductor, and the charges in remote earth will not cause a detectable surge. However, the charges are drawn from the rails, and the energy drained from these will cause a momentary potential gradient in the electrical path from remote earth. If there is a steel pipeline in this path, then it will offer a low resistance path to the returning current. But if the coating is perfect, then it will not. In order to affect the corrosion status of the pipeline, there must be a point or points of entry to the pipeline metal and point or points of discharge from the metal into the ground. When the current enters the pipe metal, it will stop corrosion, but where it leaves, it will accelerate corrosion. However, it will cause errors in the voltage measurements whether or not it is detrimental to the pipeline corrosion performance, because these measurements are not necessarily associated with the pipeline metal. Accelerated corrosion is readily prevented by the exact placement of sacrificial anodes, which must be provided with a method of continuous monitoring. This is simple to carry out, providing you have a clear perception of the electrical picture. We can construct a computer model of each situation and simply add the data gathered by our specialized survey methods. This will show the exact paths of the various currents and the exact position in which to place the sacrificial anode in each case. It will allow us to see the performance of each anode and to balance the impressed current cathodic protection systems to reach a protected equilibrium. It will allow us to reconcile voltage measurements which might otherwise be taken to indicate problems. It is sometimes advantageous to use recording voltmeters and oscilloscopes to examine the causes and likely effects of some of these ground surges.